So again, if you think back to the old way, you look at y equals x squared, x is your input, and you plot points that are of this form. And I'm thinking here of the x as being location along the x-axis, and then I figure out what the associated y-coordinate is. Well, if I go to visualize f of xy equals 1 over x squared plus y squared, the counterpart of the x is actually something in the xy plane. You guys see? So I think of the counterpart to x squared, I'm going to be graphing points of this nature. In other words, 3 dimensions. I will observe that I have a point down here in the xy plane. So this point would have coordinates x, y, 0. And that's playing the counterpart of this point, which is x0. And then I lift it up or drop it below the xy plane, depending on if my function is positive or negative at that point. And this point up here would have set coordinates. And I would tell you this point corresponds or is a point on the graph of this function, which is going to give rise to surfaces, some of which we'll be able to graph, most of which you need really good graphing software in order to get out decent pictures. Okay? We'll work with the stuff we can get reasonable pictures out without having to do too much extra work. All right? So this is one way of visualizing a function. But let me observe the troubles, or the limitations, I guess I should say. If I define g of x, y, z to be x squared plus y squared plus z squared, then my domain is in 3-dimensional space. And for me to graph g, I'm going to be graphing points of this form. I have complete freedom in choosing x, y, and z, and they get mapped to x squared plus y squared plus z squared. And this is problematic because this is a point in 4 space. I can't graph 3-dimensional space very well. 4-dimensional space is basically beyond us. Okay, so there are different ways of looking at different things here, and that's what you have to keep in mind. There are going to be a couple different ways that we will look at functions such as this, different ways of visualizing them. One of them is going to be graphing the surface that is generated. When we deal with functions of 3 variables, I am not going to ever be able to graph the surface, so I need to have a different way to look at it. Okay? And that different way is also going to be done here. Alright? So, before you totally flip out in terms of seeing things in 3 dimensions and graphing in 3 dimensions, let me observe that every one of you has likely seen things in 3 dimensions from looking at pictures in 2 dimensions. All I have to do is say, look at a topographical map. And so if I had a map like this, and if I was looking at altitude, and everywhere along this curve the altitude was 4,000 feet, and everywhere along this curve it's 3,000, and everywhere along this inside guy it is 2,000. You would be able to tell me, is this in here a valley or a hill?
It's a valley.
It's a valley, and you guys all know that. And that's going to be a way that we will have of generating some of these pictures. And it's going to be virtually the only way we have when we have functions of 3 variables. Okay? These are called level curves. The book also calls these contour curves or contour graphs. I've always heard them referred to as level curves. So we're going to want to know how to generate them. So, to begin with, let's start with a function of 2 variables. So I'll look at g of xy equals x squared plus y squared. And there are going to be 2 ways we look at visualizing this. One way is to simply graph the following: z equals x squared plus y squared, and we graph this in 3 dimensions. So this is going to take us back to that stuff in the beginning of the course of, what, chapter 11 is it? The very end, when I said we need to be able to look at these surfaces. Okay? If I make this very complicated, the chance of anybody graphing anything is pretty lousy. But this isn't too bad. Notice that z is always greater than or equal to 0. And notice that if z is equal to 0, this is going to force x and y to equal 0. And then the way in which I suggested you look is you take values like z equals 1, you generate out a circle. You let z equals 2, you generate out a bigger circle, etc. And so what we ended up with here is a shape